Hello friends, welcome back to our channel. Today in part 2.7 of our Mastering Parallel Programming series in C Sharp, we'll delve into the powerful world of parallel aggregation with PLINQ. We'll demystify how PLINQ efficiently handles aggregation operations like sum, average, min and max and explore the complexities of the aggregate operator. So before we get started, just a quick reminder to subscribe my channel, hit the red button and don't forget to click on the little bell icon. That way you'll be notified every time I upload a new video. Okay, without any further delay, let's get started. PLINQ, Parallel Language Integrated Query in C Sharp. If you watched my previous videos in Mastering Parallel Programming series, you might recall this diagram. Well, today we'll go ahead one more step further where I will be demystifying the parallel aggregation with PLINQ in C Sharp. Demystifying parallel aggregation with PLINQ in C Sharp. PLINQ works efficiently with these operators. What are those operators? Sum operator, average, mean, max. Sum is used for adding numbers together. Average is used to find their average. Min to pick the smallest number. Max to pick the largest number. So this means that PLINQ allows this operation to be performed in parallel, which can lead to improved performance, especially when dealing with large data sets. Let's see the example shown over here. Here I have written int array numbers is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this line initializes an integer array named numbers with 10 elements ranging from 1 to 10. That's what I have written, 1 up to 10, right? Then let's see the sum operation. Here I have written int sum is equal to numbers.addParallel.sum. Here addParallel converts an array numbers into a parallel query, and the sum method, it basically calculates the sum of all elements in the array. So whatever the result that we are receiving, we are storing into the variable named sum of int data type. And in this case, the sum of elements from 1 to 10 is 55. That's what I have written 55 over here. Now let's see the average calculation. How we are going to derive that? Double average is equal to numbers.addParallel.average. So here I have used as parallel, that basically converts an array numbers into parallel query, and here I have used average method. It calculates the average of all elements in the array, and whatever the output that we are receiving, we are storing into the variable named average of double data type, right? And in this case, what is the average? Average is 5.5. Now let's see the mean operation. Int min is equal to numbers.addParallel.min. So here again, this addParallel basically converts the array numbers into parallel query, and this min operation, it is basically used to find the minimum value among all elements in the array. That's what. In 1 to 10, the minimum value is 1. That's what I have written 1 over here. Now let's see the max operation. Int max is equal to numbers.addParallel.max. So here again, this addParallel converts an array numbers into parallel query, and max finds the maximum value among all elements in the array. And in this case, the maximum value among element 1 to 10 is nothing but 10. That's what 10 is going to come as an output. That's why this PLINQ works efficiently with these operators without any overhead. However, a special operation called aggregate can be challenging to speed up using PLINQ. Okay, so let's have a look the code snippet shown in two sections. LINQ Aggregate Operator with seed value, LINQ Aggregate Operator with no seed value. So in LINQ Aggregator Operator with seed value, this section, the aggregate method is used with a seed value of 0. The aggregate method iterates over the elements in the number array and performs the specified aggregation of starting with the seed value. Now let's see the examples. Here I have written int aggregate sum result with seed value equal to numbers.aggregate 0, comma, parenthesis, opening and closing parenthesis, and in between I have written total, comma, and goes to total plus n. So this line basically calculates the sum of all elements in the number array by starting with the seed value. What is the seed value? Here seed value is 0 and adding each element to the total. That's what I have written, total plus n. So total basically a variable that is going to hold the value, whatever the value where we are receiving, and it is just going to iterate one by one all the numbers. Then it will be adding all those numbers in the total variable, right? That's what this number dot aggregate 0, total, and comma, and total plus n. How it is going to derive? If you see this comment over here, I have written it start with seed value 0, 0, then 0, whatever the next iteration is there, it will start with 1, right? This is the number, for example. So here it will take 1, then 2, up to 10, and finally it will be adding all the numbers and we will be giving the output. That output I'm going to store into this variable named aggregate sum results with seed value of in data type, right? So now you have seen how we have derived this value with the help of aggregate operator with seed value, right? Now I have seen this addition operation. Now let's see the multiply operation, right? Here also I have used the seed value as a 0. Numbers dot aggregate 0 comma total comma n goes to total into n. But if you notice, it will be starting with the 0, and see this output, output is coming as a 0. Why? Because it start with seed value 0, 0 into 1 into 2 3 up to 10, it will be giving the 0 because we have multiplied with the 0. Now you have seen how we are using aggregate operator of the LINQ with seed value. Now let's see the LINQ aggregator operator with no seed value. This section, the aggregate method is used without a seed value. The aggregate method iterates over the elements in the number array and performs the specified aggregation operation without a predefined initial value, because here we are not going to provide any seed value. So it will start from the given number starting position, right? For example, number is 1 to 10. It will just start with 1 plus 2 plus 3 plus 4 up to plus 10 equal to 5 that we are going to receive it. Here I have not provided seed value. Instead of that, I have started with total comma n goes to total plus n. So this line calculates the sum of all elements in the numbers array without specifying a seed value. That's what I have not specified any seed value. And it will give us the aggregation value starting from the first element. It will start from 1 to up to 10 and it will give the output as a 50. Now if you see the multiply operation with the help of aggregate operator, what I have done here also, I have not provided seed, right? So I have written numbers dot aggregate total comma n goes to total multiply by n, right? And it is going to give me the value of 3628800. This value we are going to get it, and notice the multiplication started with the initial value, which is nothing but the 1. So 1 into 2 into 3 up to 10, and we got this number. Here if you notice, when we use the aggregate operation to add numbers with or without its seed value, we obtain the same result, which is 55. However, when we use it for multiplication, we get two different values: 0 with a seed value and 3,628,800 without a seed value. So this presents a significant challenge. So we need to be very careful when using the aggregate function, whether operation is for adding numbers or multiplying numbers, and based on that we could decide whether to imply a seed value, and if so, what value to use, whether we need to use seed value as a 0 or whether we can go for 1 as a seed value. Parallel aggregation with PLINQ. When we want to use aggregate in parallel, we need to make sure the operation we are doing can be split and combined correctly. If it can't, we might get wrong answer. So let's see two examples to understand it better. Example number 1. So here I'm trying to show you how to perform parallel aggregation with an array of numbers, showcasing seed factory, update local accumulator function, combined accumulator function, and result select. So if you see this first line of a statement, what I have written, int array numbers is equal to 1 2 3 4 5. So this line initializes an integer array named numbers with 5 elements, starting with 1 and ends with 5. 1 2 3 4 5. Now I have written int results is equal to numbers dot add parallel dot aggregate. So let's understand a step by step. Here I have written numbers dot add parallel. So add parallel converts an array numbers into parallel query. So basically it is enabling parallel processing. Now I have written the aggregate. So aggregate performs an aggregation operations on elements of the array in the parallel. And here, first of all, I have written closing opening parenthesis goes to 0. What does it mean? So this is nothing but the seed factory function that initializes the local accumulator. That's what. In this case, we have initializes the accumulator with a seed value of 0. That's what I have written. Opening and closing parenthesis goes to 0. So I have initialized local accumulator with a seed value of 0 over here. Then I have written opening and closing parenthesis, and in between I have written local accumulator comma n goes to local accumulator plus n. This statement is nothing but the update local accumulator function that updates the local accumulator for each element in the array, and it adds each element, which is nothing but the n over here, to the local accumulator. So this statement we can treat as a update local accumulator function. It is just going to perform in the local way by one of the thread. Now I have written main accumulator comma local accumulator goes to main accumulator plus local accumulator. This is nothing but combined accumulator function. What it does, it combines the local accumulators into the main accumulator. That's what I have written, main accumulator plus local accumulator. Then I have written final result goes to final result. So this line represents result selector function that performs any final transformation on the end result. In this case, it simply returns the final result without any transform. And whatever the aggregate operation performs and gives the value that we are storing into the variable named result of in data type. So in this examples, I showed how to perform parallel aggregation with PLINQ in C#, where the elements of an array are aggregated in parallel using the aggregate method, which specified seed factory, update local accumulator function, combine accumulator function, and result selector. Now let's see the example number 2, where I have used parallel aggregation with a string to calculate later frequency. So here, first of all, I have written a string str text is equal to Learn and Joy channel is awesome for learning programming. So this line initializes a string variable named str text with a sample text. What is the text? Text is Learn and Enjoy channel is awesome for learning program. Then what I have done, I have written int array later frequency is equal to first statement of the right side. What I have written strtext.addParallel.aggregate. So here again, addParallel converts the string strtext into a parallel query that enables parallel process, and aggregate function performs an aggregation operation on the characters of the string in the parallel. Then as a first argument of this aggregate method, what I have written, opening closing parenthesis goes to new int 26. So here this is nothing but the seed factory function. So this statement is nothing but the seed factory function, right? That initializes the local accumulator, and in this case it initializes an array of integer with 26 elements representing the frequencies of each letter in the alphabet. Okay, second argument is nothing but update local accumulator function. That's what I have written, local frequency comma c, and inside that we have written couple of the operation that we are performing inside this function. So this update local accumulator function update the local accumulator for each character in the string. It processes each character, which is nothing but the C over here, and updates the corresponding frequency in the local accumulator. And if you see what we are doing here, so basically we are going to get the uppercase of this character, and we are storing into this character, and then we are checking if character dot is letter upper, then what we are going to see, we are going to calculate the index of the letter in the alphabet. That's what I have written, int index is equal to upper C minus capital A, and then local frequency is index plus plus. So basically this statement, I am incrementing the corresponding element in the local accumulator. And finally, I am returning this local frequencies that we have filled it up using this update local accumulator function. Then third argument is nothing but the combined accumulator. That's what I have written, main frequency comma local frequency goes to, and in this combined accumulator function, what I am doing, I am using this zip method, add the corresponding elements to the both arrays. That's what I have written, main frequency dot zip local frequency comma f1 comma f2 goes to f1 plus f2 and then 2 array. So this statement basically adding corresponding elements to the both the arrays, and then I have written final result goes to final result as a fourth argument. This is nothing but the result select function that performs any final transaction on the end result. In this example, it simply resolves the final result, and whatever the aggregate output that we are going to receive, that we are storing into this int array named later frequency. So this example depicts how to perform parallel aggregation with PLINQ in C#, where the character of strings are processed in parallel to calculate the frequencies of each letter in the alphabet. Okay, now you have understood both the examples, how we are going to perform the parallel aggregation in PLINQ in C#, right? So let's switch to the Visual Studio and see all these things in action. Here we are on Visual Studio. Here we are going to see the demo of the PLINQ parallel aggregation. So for that, what I have done, I have created one console application named PLINQ Aggregation Operator demo that has program.cs file. In program.cs file, first of all, I have added necessary namespace. Then there is a class named program that has main method, which is an entry point of this application. So first of all, in main method, what I am doing, I'm just printing this statement, PLINQ parallel aggregation demo with the help of console.writeline state. So here I have taken one example data. What example data is? So here example data is nothing but the int array that contains the elements of 1 to 10. And in this program, I have written 3 sections. Section 1 basically deals with the PLINQ, works well with the sum, average, mean and max. That is the one demo that we are going to show you. Section number 2, what I'm going to cover, LINQ aggregate function with or without seed value. That demo that we are going to show you with the help of section 2. In section 3, we have divided into 2 parts. In 3a, we are going to show you the demo one example, and 3b we are going to show another example. That's how this program is structured. Let me go one by one and explain you what this section talks about. Okay, as I said, that section number 1, it is just going to show you the demo of how we are going to use sum, average, mean and max function in PLINQ. So if you see, I have written int sum is equal to numbers.addParallel.sum. AddParallel is nothing but a function that converts the array numbers into parallel query. And sum, it calculates the sum of all elements in the array. So this number is nothing but this integer array where this sum operation is going to get performed. So if we are going to perform this operation, we will be getting the output. That output we are storing into the variable named sum of in data, right? And whatever the value that you have stored into this variable named sum, that I am printing in console window. That's what I have written sum. Similarly, I am calling average also, min also, max also. This is the way how we are going to call average function in parallel PLINQ, minimum, maximum. So this is the function altogether, right? So here this average function, what it will do, it will calculate the average of all elements in the array. So whatever the output that we are going to receive, we are storing into the variable named average of double data type, and we are printing into the console window. Similarly, we are going to get the minimum value in that list, and then we are going to print. Similarly, we are going to get maximum value in the list, and we are going to print it console. Now come to the section number 2. Here I'm just going to show you LINQ aggregate function with or without seed value. I discussed in the previous slide itself, right? So here what I have done, I am going to use this aggregate function. This is simple LINQ query where I'm just going to use this aggregate function. So here first I'm going to show you with seed value, and then I'm going to show you without seed value. So if you see this aggregate function, I have written the seed value as a 0. Then I'm just putting the second argument total comma n goes to total plus n. So whatever the output that we are going to receive, that we are storing into this variable. This variable name I have given aggregate sum result with seed value. This statement is just going to print this aggregate sum result with seed value into console window. And see this aggregate function, how it is going to perform. It will take the seed value 0 plus 1 plus 2 up to 10. Then it is just going to give us the value as a 55 as an outcome. That we are going to see the console window when we are going to execute this application. Next, what I am doing, I am using this aggregate function without seed value. Here if you see, I have not given the 0 as a seed value. So how it is going to perform? It is going to take the first value of the int array, which is nothing but the 1. Then it will go to the next value 2, 3, 4, 5, 6, 7, 8, 9, 10. That's how just going to calculate and gives the value as a 55. With seed value and without seed value, ideally we should get the value as a 55. But you see this multiply operation with seed value and without seed value, there will be different. You see this statement, right? Numbers dot aggregate 0 total and goes to total multiply by n. So here seed value is 0. Whatever the value we are having into this integer array, it is just going to multiply with the 0. 0 with multiply with any number, eventually we are going to get as a value as an output as a 0 only. That's what you see here. 0 into 1 into 2 into 3 up to 10, it is just going to give the value as a 0. So here we have given seed value as a 0, and that's how we are going to receive an output also as a 0. But if you are not providing the 0 as a seed value, what outcome we are going to receive? So here, instead of multiplying by 0, we started with 1. 1 into 2 into 3 up to 10 is just going to give me 3,628,800 without a seed, right? That's how we are going to receive as an output over here. Okay, now let's see the section number 3a. So here I'm just going to show you the demo of the parallel aggregation with PLINQ's aggregate function. So here what we have seen earlier, it's a simple LINQ aggregate function, but here we are going to use PLINQ aggregate function. So using the PLINQ aggregate function in efficient way, we need to follow some steps. What are those steps that we are going to discuss in this section? So here what I have done, int result is equal to numbers.addParallel.aggregate. So this is the as usual statement basically we write. First of all, this as parallel converts an array into parallel query. So basically it is just going to enable parallel processing altogether. And then there is the aggregate function. So this performs an aggregation operation on the elements of the array in the parallel way. Now we need to see what are the arguments that we are going to pass in this aggregate function. That's very, very important. So here, first, this is nothing but the seed factory function. So here we need to decide, okay, what is the initial value? What is the seed value for this operation, right? So that's what. This is nothing but the seed factory function. And here I am initializing the accumulator to 0. That's what I have written. Opening, closing parenthesis. goes to 0. So here I have initialized the seed value as a 0. Then second statement is nothing but the update accumulator function. This one basically what it will do, it will add each number to the accumulator. That's all this statement is doing. Next statement is combined accumulator function. So this statement basically what it will do, it will combine accumulators. So main total plus local total, whatever the threads are going to proceed, so all those threads local total we are going to add it into the main total, and that's how we are going to combine. It will give the combined accumulate value. And then fourth one is the result select. It will just return the final result. If you have something to do transformation, we can do so over here, but right now here we are returning just simple final result. That result we are storing into this variable named result of in data type. Then I'm just printing this result value into the console window. That's what I have written a statement, some result using aggregate function, and this is the result value. Now let's see the section number 3b. What section 3b contains? Here what I'm going to show you, I have used parallel aggregation with a string to calculate later frequency. That's what I have written, one string over here, right? Str text learn and enjoy channel is awesome for learning program. This is nothing but one of the string text, right? Then I'm just printing this string text into the console window. Whenever this output is going to get printed console window, we would be able to see okay how it is related to this particular. That's what I'm just printing this statement into this console window. Then there is the int array later frequency. So this int array, it is just going to hold the later frequency values that we are receiving with the help of this operation. Let's understand this aggregate operation. So here again str text dot edge parallel dot aggregate. So here I am performing this parallel processing with the help of edge parallel. Then there is an aggregate function. So this aggregate function performs operation on the characters of the string in parallel, because in number is not there, here a string is there. So this aggregation operation is going to get performed on the string in the parallel way. In this aggregate again we need to define the seed factory function. This is the seed factory function where I have written opening and closing parenthesis goes to new int 26. So basically I am initializing the local accumulator. What exactly this new int 26 is doing over here? Here this statement initializes an array of integer with 26 elements, so representing the frequencies of each letter in the alpha. That's how this seed factory function is doing. Okay, let's move to the next statement. This next statement is nothing but the update local accumulator function. What it does is it is just going to convert the character uppercase and then checking if the character is a letter. If it's a letter, then it is just going to calculate the index of the letter in the alphabet. That's what I have written, int index upper C minus capital A. It will give the index of the letter. In this statement what I am doing, I am incrementing the corresponding element in the local accumulator. Then finally I am just returning local frequency. So this function basically updates the local accumulator for each character in the string. So next, this is nothing but the combined accumulator function. That's what I have written, main frequency comma local frequency goes to main frequency dot zip local frequency comma f1 comma f2 goes to f1 plus f2 dot to array. Here I have used zip method. Why we have used zip method over here? Because I want to add corresponding elements to both arrays. That basically represents here as a frequency, later frequency, right? And once it is done, then I'm using this to array method that is going to convert the result to an array. And final statement, final result goes to final result. This is nothing but the result selected function that performs any final transformation on the end result. But here I'm not performing any transformation operation over here because just giving you a simple demo over. So I'm just returning end result. Then what I am doing, I'm just going to print this later frequency altogether into console. So because we have alphabet as 26, I'm just iterating 26 times with the help of for loop and then just converting the index back to the corresponding uppercase. And then those letter we are receiving this letter and what are the frequency that we have in our str text, right? This text, how many alphabet, for example, let's say a how many times are there, right? So that a will be printed over here and how many frequencies is there to this particular text, that number we are going to display into console. So that's how this program is structured. Let me go and execute this program and show this output. Okay, so output got appear into this console. Here if you see this output, first statement, this statement got printed, PLINQ Parallel Aggregation demo. Then section 1, then we have used this sum, average, mean and max. That's what I'm showing the demo of that. Some value 1 to 10, it just gave the value as a 50. Average 1 to 10, it just gave the 5.5. What is the minimum value between 1 and 10? Then 1. Maximum value 1 to 10, 10. So it works well with the PLINQ with these operators, sum, average, mean and max, and we got this output as expected. Now let's see the section number 2. Here I showed you how to use the aggregate function of the LINQ with or without seed. That's what. I just performed this aggregate function for deriving this sum with seed value and it gave me 50. Second, I have performed this sum aggregate function without seed value. I got the 50. But when we used aggregate function or multiply operator with seed value as a 0, then outcome we got as a 0, because seed value, when it's going to get derived number, it will start with 0 into 1 into 0 2 up to 10, then whole outcome we are going to get as a 0. That's what 0 got printed. And here I have not used seed value. It started with 1 to 2 up to 10, then it gave me 3,628,800. Then see the section 3a. Here parallel aggregation with PLINQ aggregator function. So here I have used PLINQ aggregate function for deriving the sum result. That's how we got the result, sum result, using the aggregate function 55. Then if you see the section number 3b, here this text is printed. Learn and Enjoy channel is awesome for learning program, right? And in this text, for each letter, how many occurrence is there in this text that we have derived. That's how this letter frequency got printed. A frequency in this statement is 5 times. See, A in learn there is a 1 A, then channel there is a second A, awesome there is a third A, learning there is a fourth A, programming there is a 5A. 5 occurrence found in this text. That's how this A frequency is 5. Similarly, there is no B, then 0, C a one time, then just got printed 1. Similarly, all these numbers got printed based on the text. Okay, that brings me to end of my session. To sum up, in this video, we learned how PLINQ works efficiently with add, average, mean, and max operators, and what aggregate operator presents special challenges for PLINQ. We saw aggregate function with seed value and without seed value and understood how it processes the data. Finally, we saw how to use PLINQ aggregate function effectively with 4 delegates such as seed factory, update accumulator function, combine accumulator function, result select. That's all for this video, guys. If you like this video, hit the like button, share it with your friends and colleagues, subscribe to my channel if you haven't done already. Thanks for watching. See you next video.